On the Pythagorean Theorem, which sounds like a funny name, but it's named after this guy, Pythagoras. Okay, and you see he's holding a lovely pyramid. You'll kind of see how that has to do with this theorem in a moment. So the Pythagorean Theorem. So before we get into the theorem, first I want to talk about square root. Okay, so the symbol, it may look like a long division symbol, but it actually is square root. It's a little different. Okay, it's kind of like the little check mark. Okay. And what's important to think about is actually squaring a number. Remember, if you square a number, for example, if you square 2, it means 2 times 2, which is 4. Or if you square 3, it means 3 times 3, which is 9. Okay? Or if you square 4, 4 times 4 is 16. Or if you square 5, 5 times 5 is 25. Okay, now square root is just going backwards. It's taking a number and going the square root of 4 would be 2. The square root of 9 would be 3. The square root of 16 would be 4. And the square root of 25 would be 5. Okay, so this very first answer, the square root of 25 is 5, because 5 times 5 is 25. Okay, now you can do this on a calculator too, assuming you have a slightly high-tech calculator. Some of them don't have a square root button. But you would look for just that very symbol, square root, like this, okay? It might have a little X underneath it, which means you have to put in what the value is first, or it might just be blank, okay? And depending on your calculator, it depends. Usually you type in the number first, but sometimes you hit the square root button and then type the number. So just play around with your calculator and see what you get, okay? If you need to pause this and go look for the calculator that works for this, go ahead and pause it and try that, okay? When you get back, go ahead and try and figure out the square root for all of these, and then hit play and we'll talk about them, okay? All right, so this next one, you probably don't even need a calculator, hopefully, because hopefully you'll notice that the number, maybe the square root of 81 is 9, because 9 times 9 is 81. The square root of 144 is 12, because 12 times 12 is 144. Then we start getting into some that aren't whole numbers, right? Because there's obviously numbers in between 4 and 9, between 9 and 16, between 16 and 25 that don't have whole number square roots, okay? So the square root of 75, if I round it off, is about 8.66. Okay, so 8.66 times 8.66 is roughly 75. If I do the square root of 18 and I round it, I get roughly 4.24. And then this one, so if I do the square root of -7, hopefully you got some kind of error message, okay? Because this is what's called undefined, okay? It's undefined. You cannot do a square root of a negative. The reason is, think about it. So if I'm squaring a number, look at all these squaring numbers, it's the number times itself, okay? So if I were to do a negative number, for example, -2, and I squared it, I would do -2 times -2, which is still +4. -3 squared would be -3 times -3, which is +9. You're getting the point, right? If it's a negative number, the negatives will cancel out. If it was a positive to begin with, there were no negatives. So it's impossible to square a number and end up with a negative answer. Your answer has to be positive, okay? Because you're either doing a positive times a positive, which equals a positive, or you're doing a negative times a negative, which still equals a positive, okay? So that's why it's impossible to go backwards and do a square root of a negative, okay? So don't worry about that too much. I just wanted to point that out. But hopefully now you know how to find square root and what it is. Oh, we talked about the perfect square. So our perfect squares are those numbers we talked about. Really, technically, I should start with 1. So 1 squared is 1. 2 squared, 2, sorry, getting on a rhythm. 3 squared, we got 9. 4 squared, 16. So the reason we're talking about these is it's a good idea to know what these are. You really shouldn't have to punch these into the calculator. You should recognize these right as soon as you see them, okay? So take a look at these, familiarize yourself with them. Because if I see the square root of 81, I should instantly know that that answer is 9, okay? and it's most common to go up to 12. Okay, after that, it's okay if you don't instantly recognize that it's a perfect square, but these are all called perfect squares. Okay, so 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, and then it would keep going. Obviously, 13 squared, 14 squared, etc. are the perfect squares. Okay, and it goes on forever. The numbers in between them have square roots, but they're just not perfect squares. So the numbers like 2 and 3, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15, you get the idea. Have square roots, they're just not perfect squares. Perfect squares have to have a square root that would be a nice whole number. Okay, and like I said, it's a good idea to be able to recognize these and know what their square root is, so you don't have to waste your time punching into the calculator. All right, so on to the theorem. So this theorem is only for right triangles. So please note this, only for right triangles. So remember, right triangles means it's going to have a 90-degree angle. Okay, so if we're talking about a right triangle, we're going to name the sides, okay? So they named the two sides forming the right angle legs, okay? So these two are the legs, and they form the right angle, leg and leg. And then the opposite side to the right angle is called the hypotenuse, okay? It's funny how they use such basic terms like legs and then hypotenuse is the other one, okay? So here's a funny comic I found about the hypotenuse. It shows a kid taking a math test and says, question 9, how do you find a hypotenuse? He's confused and he says, look for tracks around the water hole, okay? So remember, hypotenuse, very similar to hippopotamus. Not sure the connection there, but those are our names. We got leg, leg, and then hypotenuse, okay? Now the hypotenuse, is going to be important to notice, is always going to be the longest side, okay? So this side opposite the right angle is always the longest one. So hypotenuse, always the longest side. Alright, so let's get into the theorem now that we have our sides named. Alright, so here's the theorem. So here's the official definition, and then I'll read it through and then explain what it means. So it says the Pythagorean Theorem states that any right triangle, okay, so like we said, it only works for right triangle, the sum of the squares of the lengths of the legs equals the square of the length of the hypotenuse. So let's look at that. So sum. So sum means addition, okay? So we're adding something up. We're adding up the square of the lengths of the legs. So the two legs in this case are A and B. So they squared A and they squared B and they added them up. Okay, so the sum of the lengths of the squares of the lengths of the legs. So squaring the legs and adding them up equals, so there's our equal sign, the square of the length of the hypotenuse. In this case, C. Okay, so C squared. Okay, so what this is saying is if you take the two legs and you square them, it will always equal the hypotenuse squared. Okay, so we can write it out this way. Leg squared plus leg squared, slide this out of the way, equals hypotenuse squared. Okay, so that's our formula. Leg squared plus leg squared equals hypotenuse squared. Okay, so let's look at some examples so you can actually see that this is true. But this is our formula we're going to use. Leg squared plus leg squared equals hypotenuse squared. Okay, so before we do that one, let me just show you one where the sides are actually filled in so you can know that this is actually true. Okay, so let's say we had a right triangle like this. And I'm going to give you measurements of what I know would actually work out as a right triangle. Okay, 3, 4, and 5. So what the hypotenuse, or what the Pythagorean theorem is saying is that if I square the two legs, in this case the 3 and the 4, because remember they make up the right angle. So square 3 and square 4. And I add them up. They will equal the hypotenuse squared. So in this case, 5 squared. Well look, 9 plus 16 equals 25. And 5 squared is 25. So it worked, okay? So the reason this is going to be helpful is you're not just going to be testing things and doing that. You're going to have a missing side. In this case, look, the hypotenuse is missing, okay? So let's use this formula, and I'll show you how to do it. If you have an idea of how you think you're going to do this, you can go ahead and pause it and try it on your own. Otherwise, follow along, okay? So remember, we got the two legs, which they always call A and B. So A and B, if you square them, will always equal the hypotenuse, which they always call C squared. A squared plus B squared equals C squared, okay? In this problem, the hypotenuse is missing. It's pretty obvious because they call it C, so that gives it away. But if they don't call it C, you see how it's this long side across from the right angle? So that also gives away that that's the missing one. So we'll leave C as C. My legs are 8 and 15, okay? It doesn't matter which is which, so just put one for A and one for B. Because remember, if you're just adding them anyway, it doesn't matter what order you're doing it in, okay? And then you're going to go ahead and square them. So 8 squared is 64. 15 squared is 225. So that equals C squared, okay? Then you're going to add them up. And you get 289 equals C squared. Now, careful. Some people accidentally say that this hypotenuse is 289, but it's not. The hypotenuse squared is 289. So this is where our new tool, the square root, is coming into place. If you do the square root, remember what I said, it's undoing squaring. It's the opposite of squaring a number. So if I do the square root, that is just C. So C equals whatever the square root of 289 is, okay? Now, not all of our calculators have it, so you can always leave an answer like that. But if you have one that does it, go ahead and do it out and figure out the square root of 289, you'll see, ends up equaling 17, okay? So our answer in this case would be 17 inches, which seems reasonable, right? It's bigger than 8 and 15, but it's not 289. 289 doesn't make sense. It's way too big, right? They're all fairly similar, close in size, but the hypotenuse should be the longest one. Okay, so the key part here that's new is that to get rid of this squared, if you do the square root, that cancels out the squared. Okay, and that's how we end up with just C down here. But you got to do the same thing to both sides, like any solving problem we've done. Do the same thing to both sides. All right, so I'm going to go ahead and pause, or you go ahead and pause it. When you sorted out your answer, hit play and check your work to see how you're doing. All right, so this time we have a leg missing. Remember, the legs make the right angle. So we've got A squared, we don't know, plus 8 squared equals the hypotenuse squared of 10. Okay, so A squared plus 64 has to equal 100. So if I take away my 64, I end up with 36 equals A squared. Okay, now that's not A. Remember, you got to do square root. So A equals the square root of 36, which you shouldn't need a calculator to figure out. The square root of 36, 6. Okay, so 6 meters is our answer, because the square root of 36 is 6, which makes sense. It has to be less than 10, because 10 has to be the longest side. 6 and 8 go together, seem reasonable. So that's your answer for that one. Go ahead and pause it, figure it out, and hit play to check your work. All right, again, we're missing a leg. So we got 7 squared plus B squared equals 25 squared. 7 squared is 49. 25 squared, I think, is 625. All right, take away 49 for both sides. We get 576 is B squared. But please don't forget, for some reason, people forget this last step, the square root. So B is the square root of 576, which, let's see what that is, 576, 24. Okay. Now, so far, all the ones we've done have been really nice because they end up with these nice whole number answers. Okay. These are special triangles that end up with nice whole number answers. A lot of triangles do not, so don't be alarmed if you get an answer that's not a nice whole perfect number, perfect square number, okay? These are special types of right triangles. All right, this next question. Find the perimeter and area of the triangle at the right, round to the nearest tenth. So this is the kind of problem you'll be seeing now when you're missing a side and you're looking for the perimeter and the area. Go ahead and pause it, try on your own, and then hit play to check your work. All right, so the side that we're missing that we need is a leg. So I need to first figure out, before I can find the perimeter and the area, I need to figure out, well, what is this? What is this side? Okay, because I need it for both, because obviously the perimeter I need it, and also area, remember, I need to multiply the two that form a right angle together. All right, so x squared equals 115. So if I do square root, x, if I round it, is about 10.7. Okay, so we'll say x is 10.7. So now I can find the perimeter by adding up these sides. So there's my perimeter. And then area, remember, is base times height divided by 2. And remember, the base and the height have to form a right angle. Okay. And so I get about 48.2. This would be inches